Okay, in this video, we're going to be doing Calc AB Problem Set 112. The problems and a playlist are in the description below. Let's see what we're doing. Values of the increasing differentiable function f of x are shown in the table above, and h of x is equal to x times f of x. We want to find the average rate of change of h of x on 2 to 6. All right, so we know average rate of change is algebra 1 slope, so let's just set that up. So it's going to be h of 6 minus h of 2 over 6 minus 2. Now we got to actually figure out what h of 6 and h of 2 are. That's a big part of the problem. So h of 6 is going to be 6 times f of 6. You look up f of 6, it's 12, so 6 times 12, which is going to be 72. H of 2 is going to be 2 times f of 2. So all these functions, when they're defined kind of weirdly, just like do it step by step, don't get afraid. They're never that bad. So we look up in the table, f of 2 is 3, so this will be 2 times 3, which is 6. So we're going to do 72 minus 6 over 4, which is going to reduce down to 33 over 2. Okay, and that's it. For b, we want to approximate the integral from 0 to 6 of h of x dx with a left Riemann sum. All right, so we're going to definitely start off with the integral from 0 to 6 h of x dx is approximately equal to. And now we just do it, right? So from 0 to 2 is 2. And then the value at the left end point is going to be h of 0, which is 0 times f of 0. So 0 times 2, which is just 0. From 2 to 3 is 1. At the left end point, you're going to get h of 2, which is 2 times f of 2, or 2 times 3. From 3 to 5 is 2. F of 3 is 5, so we're going to be doing h of 3 is 3 times 5. And then from 5 to 6 is 1. The left end point, we're doing h of 5. That's going to be 5 times 8, which is 40 if you're working them out. You could leave this on the AP exam. You definitely should. I'm going to simplify it and get 76. All right. Is the approximation in B an over or underestimate? So I think that you should be allowed to just say that f of x is increasing, x is increasing, you multiply two increasing functions, you get an increasing thing. However, this particular type of question has been on the AP exam before, and they really want you to find h prime. So I'm going to do it the way that on their like sort of scoring guidelines, they've done it in the past. I'm going to find h prime and make a giant argument about it. So first, derivative of the second, plus second, derivative of the first. So this is what I want you to do, because this is the thing that got all the points for sure. All right, now we need to just work out if this is positive or negative. It's definitely going to be positive because an increasing function times an increasing function is increasing. But f of x is increasing, that is given. And since f of x is increasing, we know that f prime is greater than 0. So we got f prime is greater than 0. Now, we also know that f of 0 is equal to 2, and we know that f is increasing, or f prime is greater than 0, which means that f of x is definitely greater than 0 on the interval from 0 to 6. If you're at 2 and you only increase from there, definitely positive. I would also say that x is greater than 0. I don't know how crazy we need to go, but on the interval from 0 to 6, x is definitely greater than or equal to 0, which means that h prime is greater than 0. And since h prime is greater than 0, h of x will be increasing. If you have an increasing function, a left Riemann sum will underestimate it. So I'm going to write that down. Since h of x is increasing, a left sum underestimates the integral from 0 to 6 h of x dx. Go through the process. Just know the advantage is that we know going into it that that's what they're looking for. So make sure you find that derivative and make your argument based on that. All right, next up. A particle moves along a horizontal axis with velocity v of t, which is cosine of t to the 1/3, and its position is x equals 5 at t equals 1. All right, and this is all calculator. So find the particle's position at t equals 3. I'm going to rearrange the fundamental theorem to get this. So I'm going to say that x of 3 is going to be what we started out at, which is x of 1 plus the displacement, so the integral from 1 to 3 of v of t dt. It's a calculator problem, so I'm just going to use a calculator to get this. So I get 5.630, and I usually write it out. I write out the 0. I like to look at all my decimals at the end and just see that all of them are 3 decimals long and not have to wonder, like, why did I not write 3 decimals? All right, is the particle moving toward or away from the origin at t equals 3? And we need to justify that. So I already know that at 3, x of 3 is 5.630, which is greater than 0. I need to know if the velocity is positive or negative. And so the reason that I need to know that I am already to the right of the origin, because if I'm to the right of the origin and the velocity is positive, I'm getting farther from the origin. If I was to the left of the origin and the velocity was positive, I'd actually be getting closer to the origin. So you really need to reference both pieces of information. So just use a calculator to find v of 3, 0.128. So I'm going to say, since x of 3 is greater than 0 and v of 3 is greater than 0, the particle is moving away from the origin at t equals 3. So make sure you reference both pieces, though. All right, what's the next thing we got to do? Find the total distance traveled by the particle on 0 to 8. So that's just going to be the integral from 0 to 8 of the speed, the absolute value of velocity. And it's a calculator problem, so calculator 2.342. There is a little warning there, and there's nothing we can do about it, but let me just show you what the warning says. Result obtained using approximate arithmetic. It's a little unsettling that you would get that as an answer, or rather as a warning if you're like taking the AP exam. But as I mentioned, there's nothing you can do about it. It just is warning you of that. I've never seen it be wrong, so I wouldn't really worry about it. Anyway, that's the entire problem set. I hope this was helpful, and good luck.